Good morning, everyone. My name is Anjan Dave. I'm a corporate advisory engineer with Dell in the Unstructured Data Solutions division. Today, I'm going to talk about our scale-out high-performance NAS called PowerScale as relevant to the high-performance computing environments. So first, let's talk about traditional HPC. It's all around us. In fact, if you look at manufacturing as an example, computer-aided engineering or CAE applies to simulation and modeling tools used in mechanical engineering, such as in automotive and aerospace industries, as well as consumer packaged goods, petroleum companies, etc. And then there's the electronic design automation or EDA, where simulation and modeling tools are used by semiconductor chip design companies. Now, if we look at life sciences as an example, we have pharmaceuticals and biotechnology. And in medical research, there's much focus on genetics and next generation sequencing and bioinformatics as a tool for creating personalized medical procedures, as well as design of new, more effective drugs to combat diseases. So through all of these, we see some key trends. Continued growth in the insatiable demands for the HPC performance, enabling their innovation, and more importantly, even faster growth in data volumes. This combination of compute and high volumes of data have led to the emergence of high performance analytics relying on big data. So HPC via integrated scalable systems is critical for all big problems that require faster, better answers. So for example, modeling and simulation are traditional HPC apps, which include high performance computing and high throughput computing clusters. You could also have big data, which deals with high performance data analytics for rapid insights on data intensive problems. And finally, cloud computing can simplify usage and management of integrated and scalable systems. So therefore, the future of HPC intersects with both the big data and the cloud, and Dell EMC has solutions in all these areas. The Dell EMC coverage of the entire IT spectrum of enterprise data, cloud, etc., enables it to provide the most comprehensive, capable, and cost-effective HPC solutions for diverse applications, workloads, and customers. Dell EMC provides ready bundles for HPC for all areas that need better, faster solutions to solve problems, with extra focus on key markets that require HPC solutions now, which includes research, federal, energy, life science, manufacturing, and finance. So this brings us to PowerScale, which is the topic of this presentation. One of the most, if not the most important considerations regarding unstructured storage, especially in the world of HPC, is to ensure that complexity, risk, and administrative overhead don't increase while scaling performance and capacity. This is the central challenge for all enterprise class storage systems being used to manage data sets that grow at exponential rates. If administrative effort and complexity increase as your storage environment grows, you are assuming risk both from a cost and complexity standpoint that can often get out of control. Likewise, it's easy to back yourself into a corner, limiting your ability to quickly adapt to a new business need. So scale out NAS must start simple and stay simple at any scale. So when we look at the PowerScale platform from this point of view, we scale from a few terabytes to tens of petabytes, all in a single namespace, while delivering performance that is just right for you over multiple protocols. And it's not just the performance and scale, but it's important to bring that data experience anywhere, from NVMe-based all-flash nodes to edge to cloud, and to be able to get intelligent insights into that data and the systems. So going a little bit in depth, What's latest with PowerScale? Well, first the PowerScale is now the family brand that encompasses what you've known as Isilon since it was first shipped in 2005. That is the OneFS software residing on the current Isilon 6th generation nodes, or on the newly introduced PowerScale nodes, which includes F200, F600, F900. So at Dell Technologies, we are doubling down on the OneFS software, which has driven the solution since its inception. OneFS is still the core software that lives on all hardware in the portfolio. Whether it's Isilon, chassis-based nodes, PowerEdge-based nodes in the cloud, or future platforms. So we have recently introduced our highest performance PowerScale F900 node. You can see the details here in the slide. It's based on the Dell R740XD server. It gives 30% better performance over the F800 Isilon node. It's an all NVMe based node with 100 gig Ethernet connectivity for both front and back end. But it's not just about the speeds and feeds. Performance boosts are not just from the new hardware. We've optimized the 9th generation of OneFS to deliver more performance. OneFS 9.2 speeds up the F600 as an example by up to 70% for sequential reads by taking advantage of its multi-process capabilities. A recent research by Forrester on Total Economic Indicator study showed that the F900 powered by OneFS can deliver an ROI up to 374% and a payback period of less than 6 months. That's amazing. Ultimately, it's about the power of OneFS that enables administrators to focus on managing their data and not on storage. Another noteworthy thing here is the introduction. With the introduction of 9.2, we now support NFS over RDMA to help accelerate certain applications. This is available on all nodes that are configured with 40 gig Ethernet interfaces and higher. This just needs the RDMA driver on the client and works on the Rocky 2 protocol, by the way. So we have also refreshed the hybrid and archive family of nodes with faster CPUs and more memory, 100 gig connectivity, as well as inline data reduction, which includes inline compression as well as inline dedupe, which is across the PowerScale family at this point. Together, this delivers an unmatched value to our customers. Our customers who have already invested in Isilon nodes enjoy the benefits of the new nodes. As usual, with a broad compatibility, adding the new generation node to your cluster takes just minutes without any disruption to the end users, as you can see here. So additional space and file compute processing power is available immediately while the data is auto-balanced across the nodes. So we have customers today who are using 3 generations of Isilon nodes. They keep adding new nodes as they become available generation after generation and take out the old nodes, all while maintaining that single namespace, single file system, and maintaining the transparency to the clients. There's no impact to the users. So this is the PowerScale family. The introduction of PowerScale marks the next evolution of OneFS, providing access to the full power of Dell technologies, enabling us to thoroughly exploit hardware advancements faster than ever before. Today, the Isilon Gen 6 nodes still provide incredible density, performance, and a wide range of options, whatever your unstructured needs are. We also have our PowerScale integrations in the public cloud as seen on the right side of this slide. where we have a very unique and powerful multi-cloud capability to help our customers take advantage of the economies of scale for compute power in the cloud for HPC applications, while using the PowerScale as a decoupled file data storage target for a variety of workloads, uh, HPC or the modern HPC, data analytics, AI, etc. The PowerScale is also available as a fully integrated file solution inside the Google Cloud Platform, allowing customers to marry benefits of Google Cloud and PowerScale platform together. When managing a data set that has enormous mass and is growing quickly, it's important to think through how you will provide maximum flexibility when granting access to the data. In these scenarios, it's simply not feasible to bring the data sets closer to the applications and clients, except maybe the RDMA, NFS or RDMA. So accordingly, you must think about the data first by ensuring you can provide rapid access without having to move it or modify it or change existing workflows. So in many cases, the agility required to rapidly adapt large data sets is difficult to achieve. And as a result, you can miss strategic business transformation opportunities. One pathway to success is to ensure there are many routes to your data, along with a robust method for offering any client or application access to that data. Moreover, this must be accomplished regardless of the required protocol, all while maintaining centralized and manageable security. This is where the OneFS implementation of multi-protocol provides differentiated value. You can provide access to the same data set via any of the protocols we support, including both file and object semantics. Dealing with authentication and ensuring a single security model, one that is both easily managed and predictable, presents a massive challenge when it comes to protocol access, and a challenge for which OneFS was purpose-built. So throughout that life cycle, in order to provide critical file system data services, OneFS includes a robust suite of capabilities to handle file system needs in the enterprise. One of the primary design goals of the PowerScale family is simplified management. And the key to accomplishing this is to remove abstractions and manage by policy, which is precisely how you do it in OneFS when managing features such as snapshots, replication, compliance, locking, quotas, and tiering. In OneFS, you don't have the traditional concepts of RAID groups, pools, and other abstractions. So you're simply focusing on managing files and folders and setting a policy. Just like with data protection, you select a folder at any level, set a policy, and let the system take care of everything else. All of the enterprise features with PowerScale's ability to linearly scale capacity and performance, we can enable our customers to leverage their unstructured data, whether it be on PowerEdge with our PowerScale nodes, to the core and to the cloud. And finally, this is talking about the intelligent insights about the data. Right? When you have data that's distributed across many locations, the edge, cloud, on-prem, across systems using many protocols, both file and object, you need a way to gain a full visibility of your data footprint, regardless of where the assets sit. Equally important is automated and intelligent system health information that you can access from anywhere. So to meet these needs, PowerScale leverages three key tools here: Data IQ, Insight IQ, and Cloud IQ, which together deliver predictive capacity projections to monitoring of clusters, to analytics and data classification. There's a lot more I can talk about this on this slide alone, but I'll leave you here with the key information, which is the 3 tools that come with PowerScale: Data IQ, Insight IQ, and Cloud IQ. So that's the end of my presentation. I want to wrap it up with a recent case study that you can also find online about Arizona State University. See, that's ASU Research Computing gives the university community access to a Dell technology-based supercomputing cluster that has 14,000 plus CPU cores, more than 300 GPU devices, about a petabyte of scratch storage in a high-speed parallel file system. And there's 4 petabytes of the Dell EMC PowerScale scale-out network attached storage that I was referring to here in these presentations. So what we are hearing from ASU is that their usage numbers tell the tale of the popularity of the HPC cluster. So over the past year, ASU has delivered an average of 8 million core CPU hours per month. In any given month, 500 to 600 users put the system to work. And over the course of a year, there's about 1,500 or so distinct users that make use of the system. So it's an excellent example of a combination of HPC, scratch space systems, as well as the scale-out high-performance NAS system. So I'll end there. Thank you very much, and I'll take any questions either live or through the chat. Thank you.